Okay, so the diagram here, we've got two curves, C1 and C2, and they're both defined from 0 to pi by 2. I want the polar coordinates of the point A on C1 at which the tangent is perpendicular to the initial line. So the condition, if a tangent is perpendicular to the initial line, then dx by d theta equals 0. Now, we know that when with the link with Cartesian and polar coordinates, x is equal to r cos theta. So we were talking about C1, so we're talking about r is sine squared theta. So that's r equals sine squared theta cos theta. And now I'm going to differentiate that expression. So to find dx by d theta, I got a product rule. So sine squared theta is sine theta squared, cos theta, so differentiating the sine, that's 2 bracket to the power of 1 times the differential of the bracket, and differentiate cos theta is minus sine theta. So dx by d theta, multiply those together, so that's 2 sine theta cos squared theta, and then those minus the sine theta times sine squared, that's sine cubed theta. Now I impose the condition that equals 0 if it's perpendicular to the initial line. So I'm solving 2 sine theta cos squared theta minus sine cubed theta equal to 0. Okay, doing that. Sine theta is a common factor, so I'll take sine theta out. And I've got 2 cos squared theta minus sine squared theta equals 0. So sine theta equals 0 is one solution to that equation. The second one, 2 cos squared theta equals sine squared theta. So 2 is equal to sine squared theta over cos squared theta, giving me tan squared theta equals 2. So tan theta is plus and minus square root of 2. Right, so I've got three situations then. Sine theta equals 0, tan theta equals square root of 2, and tan theta equals minus the square root of 2. Now if sine theta equals 0, then we're getting the angles of 0 and 180. At 0 you can see that you can't, it's that we haven't got the tangent, okay, perpendicular to the initial line at 0 there. You can see it's not coming straight down, right? So theta equals 0 there, right? There's no solution of this one. Tan theta minus equals minus root 2 gives me an obtuse angle, so there's no solution on that one. So the one that's going to be giving me an angle between 0 and pi by 2. Okay, I say we wanted it at A is there, so that's why I've discarded the origin. Okay, that can't be there. So if tan theta is root 2 and theta is tan to the minus 1 of root 2, and this is in radians, so I need to make sure my calculator is in radians. Shift setup 4, so I'm in radians there. Shift tan square root of 2, and that's 0.9553166 and so on. It doesn't give me a degree of accuracy, so I'll put that to 2 decimal places. That's it, is 0.96 radians. And I want the polar coordinates, so I now need the corresponding value of r. So r was sine squared theta, so r is the sine of 0.96 squared. So if I sine the ants there, and square it, get R to be 2/3. So the polar coordinate is 2/3, comma 0.96. Okay, part B, I want the area of the shaded region enclosed by C2 in the initial line. So to find the area, that's the integral of a half r squared d theta, and that's go from 0 to pi by 2. And the equation of C2 is r is 1 minus sine theta. So this is half the integral 0 to pi by 2, 1 minus sine theta all squared d theta, which is a half. I need to expand that bracket, so that's 1 minus 2 sine theta plus sine squared theta d theta. So I can integrate 1, okay, I can integrate sine theta, write sine squared theta in the double angle formula. So I know the cos 2 theta is 1 minus 2 sine squared theta. Rearrange it, 2 sine squared theta is 1 minus cos 2 theta. So sine squared theta is a half of 1 minus cos 2 theta. So bring it back into this integral. 1 minus 2 sine theta plus half of 1 minus a half cos 2 theta. Theta is a half the integral, right, so that's 3 over 2 minus 2 sine theta minus a half cos 2 theta. Theta, integrate this up, so from 0 to pi by 2, so that's 3 over 2 theta minus integral of sine theta is minus cos theta, so that's plus 2 cos theta minus a half, integral cos 2 theta is sine 2 theta over 2, so that goes to a quarter there, between the limits of 0 and pi by 2. So that's a half, put pi by 2 in, so that's 3 over 2 pi by 2 plus 2 cos of pi by 2 minus a quarter sine of 2 lots of pi by 2 sine pi minus a half, and put 0 in. That's 3 over 2 times nothing, that's nothing, plus 2 cos of 0 minus a quarter sine of 0. And just calculating this out, it's 3 pi by 4. Cos of pi by 2, that's cos of 90 is 0. Sine of pi is 0. Second bracket, cos of 0 is 1, so that's 2. So that's 3 pi by 8, and half of 2 is 1 minus 1. So evaluating that, that's 3 pi on top over 8, take away 1, that's equal to 0.178097241, which is 0.178 to 3 decimal places.